Proposition 39. When our year has 9 digits in it, then we might begin to see the start of the eventual transformation of our web of cosmic filaments into a more defined, nested structure of co-moving frames of reference. But that metamorphosis could take hundreds of quadrillions of years. Proposition 40. Over the next 420 quadrillion years, Laniakea and Shapley may become a gravitationally bound spheroid, even though current evidence points towards them spreading apart. Gravity can work over great distances in ways we do not yet fully grasp, as seen in the outer arms of many galaxies spreading out as slowly as they do, and we may not yet truly appreciate how dark matter at large scales may help fight off dark energy when the primary attractors are themselves hurling through space-time. Proposition 41. Our largest measurable co-moving frame of reference, our visible universe, would in fact have an approximate center. However, since we will unlikely ever locate the outer edges, this almost certain fact, treated by many as mere speculation, might never be proven, at least not by our species. Proposition 42. Our entire visible universe and the co-moving parts beyond our visible horizon that are gravitationally bound have an approximate center of mass, approximate axis of rotation, period of rotation, magnetic field, electric field, gravitational field, a period of revolution, possibly one or more satellites, and within its parent frame of reference would have some average luminosity, average thermal signature, approximate relative trajectory, and an approximate relative velocity. Proposition 43. There are habitable planets on the very edges of our visible universe that could see an almost pitch-black night sky in one direction and a normal night sky in the other. Some of the possibly trillions of planets that are in edge-of-universe galaxies, if lucky, might see one or more of our pocket's siblings, far off and faint like a distant star. Just as entire galaxies can look like a distant star, without sufficient resolution and exposure, so would entire universes like ours appear to their distant siblings. Proposition 44. All the evidence of what general relativity has shown happens inside our visible patch of spacetime, when extrapolated against infinite space, indicates a clear picture of how our universe is likely structured beyond the horizon we can never see past, offering a far more elegant answer to creation than extrapolating a single hot, dense center that once held all the mass and energy of the entire universe inside a pea until it fluctuated at quantum scales with unfathomable heat, inflated faster than light, and created cold dark matter. Proposition 45. Anyone who claims to have proof of the hot, dense center of the Big Bang is in fact referring to a model that is held together by Band-Aids, unable to explain more mysteries than it seems able to solve. It offers a very detailed, almost plausible explanation from mere fractions of a second after some event happened, and has been constantly adjusting theory to help fit square pegs into round holes for over a century, all due to an assumption that once made sense. Proposition 46. What we do know is that there was a period of cooling, possibly hundreds or thousands of years, where stray electrons and random nuclei cooled to about 3,000 Kelvin, atoms could begin to form, and photons could begin to move freely. "Let there be light" rang out across our universe during a period of recombination. We know what happened, and we know about what evolved after it. But the absolute truth is that we do not yet have a good model that can match all our observations using a hot dense center as the starting point. there is a feasible method of seeing Big Bangs happen. Proposition 47. Cosmic simulations like the Flamingo Project, CODAL, Thessen, Uchu, Illustris, Deuce, Horizon Runs 2 and 3, Sibelius Dark, Eagle, Millennium, and others could benefit from removing the assumption of a hot dense center from their code. Those simulations that don't start from a hot dense center, but instead only rely on data collected from the CMB forward, then apply good physics on top of that, and then continue to zoom out, will eventually be able to replicate Big Bangs. Relative impacts of random collisions between immense nested pockets of spacetime leaves many universes like ours in their wakes. Proposition 48. If time is eternal and space is infinite, then occasionally two immense nested successions of co-moving frames of reference cross paths where the kinetic energies of the collisions that occur potentially reach or exceed twice the speed of light. Proposition 49. Our cosmic speed limit is based on our succession of relative co-moving frames of reference. The relative speeds involved when two immense pockets far removed from our scale factor intersect could potentially far exceed twice the speed of light. The physics behind those types of superluminal collisions is what turns mass back into hot, dense, swirling plasma energy. Proposition 50. There are so many separate inconsistencies and unanswered questions surrounding the current Lambda CDM model that are answered by successive collision theory with simple elegance, using just the math of general and special relativity. It offers not only a better explanation for what we observe around us, but also a better explanation for the catalyst that caused our Big Bang to occur in the first place. Proposition 51. When we don't rely on a century-old assumption of a hot dense center, but instead start with a relative field of initial collisions much closer in size to our initial CMB than to a P, then early mature galaxies, early massive black holes, and even stars older than our visible patch of spacetime are no longer mysteries, but become predictions. Another prediction would to someday see a blue shifted galaxy appear on the cosmic horizon. Proposition 52. Rather than invoking faster-than-light inflation to answer the horizon problem, it is faster-than-light collisions that helps explain where the fairly uniform temperature of our CMB came from. Proposition 53. When we change the approximate starting area from something smaller than a P to between 70% to 80% the approximate size that the CMB was during recombination, then instead of 380,000 years of cooling, we may only need 380,000 weeks of cooling to see an average mean temperature uniformly approach 3,000 Kelvin. Proposition 54. Our CMB did not form instantaneously, but over a period of time. What we call anomalies in the CMB are based on how long that area took to reach a temperature where nuclei could finally begin capturing electrons, atoms were forming, and photons could travel freely. Since that did not happen all at the exact same moment in time, we would predict subtle anomalies, and the fact that it seems so uniform is predicted when there is an expectation of similar amounts of kinetic energy being released across a large patch of spacetime. Proposition 55. It seems almost ironic that we call the period of time where electrons could begin to orbit nuclei and atoms could form the period of recombination. One might think that if our human brains really meant to call our Big Bang a starting point for everything and claim there was actually a first moment in time, then we would have called it a period of combination, not recombination. By calling it recombination, we already basically accept the probability that the hot, swirling energy that our universe was created from was previously mass. Proposition 56. Two immense intersecting nested pockets of mass and energy will see an overwhelming number of the initial collisions occur with very similar degrees of kinetic energy, turning colliding mass into heat, light, and swirling plasma radiation. The multitude of secondary and tertiary collisions would have also been occurring with similar relative degrees of kinetic energy to spread that heat and plasma fairly uniformly across our cosmic web of superfilaments and supervoids, which began forming before the CMB. Proposition 57. Superclusters like Laniakea do not look like mass expelled at faster-than-light speeds from some dense center, but do look like the remnants of successive collisions. So many current problems that our best simulations struggle with will disappear when they tweak the parameters of what we might predict would happen during superluminal collisions and remove the assumption of a hot, dense central singularity. Proposition 58. Multiple successive collisions at relative speeds at or above twice the speed of light, happening across a large area of nearby spacetime with two separate specific sets of relative trajectories and two separate sets of specific relative velocities, would be predicted to create supervoids, slowly rotating massive filaments with cross strands, multiple types of different galaxies, many galaxies that appear to rotate at the same rate, many galaxies that appear to host a quasar with a similar relative inclination of their axis, approximate 50-50 split across all three spatial dimensions in rotational directions of galaxies, and a clear explanation for why we have far more matter than antimatter. Proposition 60. One possibility is that within any two separate nested co-moving frames of reference, the fastest possible internal relative velocity could be the speed of light. So when any two pockets intersect, the highest possible kinetic energy release would be equivalent to collisions occurring at twice the speed of light. The other possibility is that collisions could have occurred with the kinetic energy equivalent of collisions at 8, 42, or 67 times the speed of light. Pockets with huge numbers of nested levels, tens or hundreds of thousands of rungs, could easily see collisions surpass double the cosmic limit. Proposition 61. This planet has unlikely ever seen a divine miracle, nor are we here because of fate. This world's first miracle would be our species flourishing 200, 2,000, and 2 million years from now. We are headed down a path of self-destruction, and only major changes in how this world runs is going to save us. But if that miracle happened, and we did become interstellar travelers, then I predict someday we will find some asteroid or meteor, or maybe even some moon, that is confirmed to be far older than the possible oldest age of our universe. That would be final proof for successive collision theory.